Welcome into part 2. We have moved on from parametric and we are going into polar coordinates. Oh, it's good today. Polar coordinates. And so the idea is here, we're going to talk about both directions, but we're going to work on going from our standard xy, right, which we would typically call Cartesian coordinates, or right, the points living inside a plane, and we want to go to polar coordinates. Now polar coordinates have an r here and an angle, right? So r is for radius and theta is for the angle, right? So just to get a visual representation of what I'm referring to, you can imagine, let's just do quadrant 1 here. If I have a point in space, of course this has some x value associated with it. We'll just call this little x1, and some y value associated, pretend that's straight line, y1. So of course we can identify this as xy, but we can also go straight from the origin, draw a line to this point, and the distance, right, this will be the radius, a radius here, so whatever distance it is to the point from the origin, and it will have an associated angle, theta, with it. All right, so another way to identify points. Now the question is, why would we do this, right? Why would we go from xy's to r thetas? Well, in some cases, let's put reasons over here, right? We'll just put reason. The main reason is easier, let's say, to integrate. All right, easier to integrate. Some examples that you would see would be magnetic fields, right? They follow, we'll get into polar equations as well, but sometimes they move in a circular path, so switching over to polar coordinates is going to make the integration easier. What else do we have? And also magnetic and electric fields. All right, so for all the engineering people out there. All right, so we do have a reason for doing so. For right now, we're going to work on going one direction. So I'll do a quick example here, same as usual, and then we'll do another example after the slide. So one example that we will do, first we need to know, first we're going to go from, let's do from polar. So we'll draw two directions. We're going to go from polar, though, to Cartesian. So we're going to go the opposite direction first. All right, so what we have here is x is equal to r cosine theta, and y is equal to r sine theta, right? Now there's other things that I'll add on to this at the end once we get into our third example, but for right now, if we're just going in this direction, polar to Cartesian, right? If you give me some r and some theta, I can give you an x. If you give me some r and some theta, I can give you a y, right? So this makes life easy to go in that direction. So let's do one example here, and then the next one we'll have a couple more examples. I'll try to do a drawing as well somewhere if we have space. So example 1, we want to convert 2, 3 pi over 4 to Cartesian, right? So this isn't polar, right? This is my r, and this is my theta. Right, so let's do a quick drawing too. Let's go through the calculation, then we'll do the drawing. Okay, so let's find what x is equal to. So in order to do this, we do need to have some knowledge of a trig circle. So x is equal to r, 2, cosine of 3 pi over 4. So knowing the trig circle, right, very helpful. And we can simplify to anybody cosine of 3 pi over 4. All right, so I'll do it down here in case we forgot. All you need to know is quadrant 1. Right, so pi over 4, right, would be the associated reference angle. And this has a cosine value of rad 2 over 2 and a sine value of rad 2 over 2. Right, so now think about this. If we're flipping into the second quadrant over here, right, my x's are negatives, my y's are positives. So that's reflective here as well. So if I do cosine of 3 pi over 4, which is over in the quadrant 2, I'm going to have the same value, but it will be negative. All right, we can simplify this. We'll just do this in the same line. We just get negative rad 2. Easy enough. Same thing for y. Now you might be able to see already what it's going to be. Y is going to be equal to 2 sine of 3 pi over 4. Well, what does that equal? Well, the 2 still comes down. Now all the y's over there in the second quadrant are still positive, so this is the same value, rad 2 over 2, and we just end up with rad 2. So our associated xy value is negative rad 2, comma, rad 2. Let's see if I have any room to draw. I'll use this corner just to depict what happened here. If we already got it, great. Feel free to move on to the next example, but just so we have some sort of visual, let's pretend we draw this straight down and we'll just go another xy chart right below. Right, so if we had 2, 3 pi over 4, that means, I could even draw it here. I'll draw it above. 2, 3 pi over 4 goes in this direction, right? And this radius here, so you could think of this as a dot, this radius has a value of 2. The angle from here is 3 pi over 4. So what we're doing is we're finding the associated x and y value. So if we drew a line straight down, right, my x value would be negative rad 2, and my y value would be rad 2. I'll utilize space a little bit better, but because we had to do the intro as well. So next example, I'll do a few more of these. I'll try to do a few more graphs as well so we have a better visual, and we will go from there. All right, I will see you in the next example. Jumping back into the same type of problems that we were just doing, but I'm going to remind us, see if I can get this, of what we need to translate. Again, we're going from polar, so let's see, there we go, polar to Cartesian. All right, that's what we're doing here first before we go the other direction. And as a reminder, right, x is equal to r cosine of theta. See if we can get this other one to work. And y is equal to r sine of theta. See if we can turn this up a little bit more. Where is this? Hopefully that's a little bit better. Okay. So we have 3 more examples to do. Let's go ahead. I'll write them up here so you guys can go through them at your own pace if you want. We'll do 3, and we'll do 5 pi over 4. So similar to our last one. We'll do negative 9, so to mix it up a little bit, negative 9 and 2 pi over 3. And lastly, we'll do 8 and negative pi over 6. Cool. And over here, just so we have a visual, I'm going to try to do a drawing. What do we have? Third quadrant, second quadrant, fourth quadrant. So we do need the full graph. Okay, so first one, let's just write it out. We have 3 and 5 pi over 4. Right, so 5 pi over 4 is in the third quadrant, and we have a radius of 3. So I just draw the full line, but the dot is really about here. Right, our radius is 3, and this is saying this entire angle here is this 5 pi over 4, right, is our theta. So let's go ahead. X is equal to r cosine 5 pi over 4. Right, and again, we need to know our reference angle, so this is pi over 4. X here is in the third quadrant, so we know it's going to be negative rad 2 over 2. So again, the faster we are with the trig circle, the easier this problem becomes. Right? This becomes negative 3 rad 2 over 2. And we can do y is equal to 3 sine of 5 pi over 4. And again here, think about what our y is. Our y is also negative. Let's see if we can get this to show up a little bit better. So this is also going to be a negative rad 2 over 2. So same thing, equals negative 3 rad 2 over 2. So our final answer, x and y here, we have the point negative 3 rad 2 over 2, comma, negative 3 rad 2 over 2. Awesome. Okay, let's just draw a line straight down to separate. And that should make sense, right? So your x-coordinate, your y-coordinate, and your x-coordinate go straight down, right? They're both negative values. They're both equidistant away from that point. Okay, so I would say once you've done this and you have these other two, maybe pause the video, try them yourself before you let me continue on here. And again, think about what's happening. So notice here I've thrown a little bit of a twist in. We still have 2 pi over 3, but a negative 9. What does a negative radius mean? So think about in this case what's going to happen. The 2 pi over 3 is going to be over here, right? This is the angle for 2 pi over 3, but because the radius is negative, you could think of this arrow, or this angle here, is going to flip to the other side. So it's going to go in this direction. So really, I'll put a dot way down here, right? Pretend this line goes all the way through, so this negative radius brings it all the way over to the other way, and pretend this is a distance of 9 here, but it flips, so it'd be negative 9 for the radius. All right, so that's our visual. So you can imagine, if we're in the fourth quadrant here, we're going to have, right, positive x and then negative y. That's what we should end up with if we've done everything correctly. So let's go ahead, 2 pi over 3, yes, okay. So we have x is equal to negative 9 cosine 2 pi over 3. So again, knowing our trig circle, and hopefully the writing is not too small, and I'll write this one down here, y is equal to negative 9 sine of 2 pi over 3. So cosine of 2 pi over 3, we need to know the associated reference angle that's over here. And so it would be, let's think, it goes rad 3 over 2, so this is going to be a 1/2. So x is equal to negative 9 times negative 1/2. Right, so again, the reason is here, I'm just going to draw the first quadrant at pi over 3. Right, so this is the reference angle that we need. We have a value here of 1/2 and rad 3 over 2. Right, so if I flip into the second quadrant, right, which is where this 2 pi over 3 is, we end up with a negative 1/2, and we just end up with 9 over 2. Okay, let's go ahead and do this one. Sine of 2 pi over 3, right, I already wrote it out for us. So we have negative 9 times rad 3 over 2. We simplify, which is not much, and we have our x and y coordinate. Right, and again, that should make sense because the y, or the x here is positive, right, positive x, and we have a negative y. Okay, so again, once you've gone through that one, pause the video, try out this one for yourself. What is the twist on this one? I've used a negative pi over 6. Okay, so what is the difference between the negative right angle and all the other angles we've used, the positive angles? Notice that I always travel counterclockwise when I have a positive angle. And so when I have a negative angle, that means I just travel clockwise. And so what I'm going to do to start off with, I know that if I travel negative pi over 6 clockwise, that's the same as traveling 11 pi over 6 counterclockwise because they have to add up to 2 pi. So I'm just going to rewrite this immediately as 8 and 11 pi over 6. Okay, so this is what we really want to evaluate. I'll write out our next spot. So we have x is equal to 8 cosine 11 pi over 6. And we have, I guess I'll write it in blue, y is equal to 8 sine of pi over 6. So what does it come, or 11 pi, sorry, 11 pi over 6. So what does it come down to is just evaluating from the trig circle. So again, the reference angle here is pi over 6. So let's see if I can draw it. The reference angle here is over here, pi over 6, which in this would be rad 3 over 2 and 1/2. Notice that these two just switch places essentially. This is pi over 6 here. And this one, I know I'm drawing as much as I can in a small space, pi over 3, right? So they just change. So I'm still positive x territory, right? So this is 8 cosine of 11 pi over 6 would be positive rad 3 over 2, which just gives me 4 rad 3. And sine, right, is negative. So it's a negative 1/2 because it's the y value. So I have 8 times negative 1/2, which just gives me negative 4. So finally, right, we have a value here of 4 rad 3 positive and negative 4. And we can kind of go check with our graph. Right, actually I didn't draw this one, but the idea would be, right, it would be somewhere over here. So positive 4 rad 3, positive x value, negative y value. Again, this is just a quick sketch to get the idea. Okay, so that takes us to the end of polar to Cartesian. We're going to go Cartesian to polar coming up. All right, thanks everyone. Now that we've gone one direction, right, we've went from polar to Cartesian, we're going to go from Cartesian, let's see if we can get this. We'll try again. There we go. Cartesian to polar. Okay, so we need some other equations that go with that. So we need x squared plus y squared is equal to r squared. So this gives us a method on finding r. And we also need tan of theta. So let's break this down from what we remember. We said before, as an aside, x is equal to r cosine theta. Y is equal to r sine theta, right, from the other direction. So if we just broke this down, r sine theta, right, this is just trig property. Tangent is equal to sine over cosine, which is also going to be equal to y over x, right? So now we have a way of finding theta. We'll have to do tangent inverse here, but we'll get to that in a sec. Okay, so these are the only two new rules that we've added. Going from Cartesian to polar. So let's jump into an example. Maybe we'll do two. We'll have, let's do a little line here. Let's do 6 rad 2 and 6 rad 2. Keep using the yellow as it appears the blue is not working. Okay. So first thing we'll do the easy part. This one's a little bit easier when we're not dealing with the angles. Let's go ahead and find r. So I know that x, which is 6 rad 2 squared plus 6 rad 2 squared. So let's just figure out what this is equal to. Well, the 6 gets squared, right? That's 36. The 2 gets squared. The rad 2 gets squared, so that becomes just a 2. And this is identical. This is just 2. So what do we end up with? 72 plus 72, or 144. Right? Well, now that's not our radius, because what did we say? We said x squared plus y squared is equal to what? R squared. So r squared is equal to 144, which means, right, r is just equal to, we have two answers. We have 12 and we have minus 12, right, or negative 12. We'll discuss each one. Okay, so that takes care of the r. Now we have to do what tangent is. Well, this one's a little bit trickier. Let's see. Tangent of theta, let's try blue again. Tangent of theta is equal to 6 rad 2 over 6 rad 2, which is equal to 1. Right, so now the question becomes, when does tan of theta equal 1? Right, so we want to know tan, let's do theta, draw a line here. Theta equals tangent inverse of 1. And so there are two answers here. We're going to find the easy one first. So think about the trig circle, right? Again, we have the x over y here that are equivalent to the same thing. So think about your normal trig circle, right? And think about this angle pi over 4. Right? They both have the value of rad 2 over 2. So if we try to divide them by each other, right, we'll get 1. So I know this is pi over 4. That's one of my answers. Right? So one of my answers is I have pi over 4 here, right? And my radius is going to be the positive 12. Why? Because we're moving, right, in the direction of the angle. I'm moving in the direction of the angle. So I have one answer. So there's one answer where if r is greater than 0, right, on your homework it'll ask for two different options. One where your r is positive, so greater than 0. We have 12 and pi over 4. And it'll ask you for another one that says, what about when r is less than 0? And so we have negative 12, but remember, we want to end up at this same point. We want to end up here. Right now, my negative 12 is flipping me in the other direction, right? It's flipping me down this way. And so what angle do I want to use if I want to flip back the other way? So the idea is here, if I add pi to pi over 4, right, I'll get 5 pi over 4, which will take me here. Right, this is 5 pi over 4. And then by using a negative radius, it'll flip me back to where I want to be. So this is kind of the trickier one, using the negative radius. So think about, if I'm using a negative radius, I want to be 180 degrees away from where I'd like to end up at. Right? So I used 5 pi over 4. I traveled all the way. Because I'm going to have a negative radius, the negative radius lets me flip back over across into quadrant 1. Right, so those are our two different answers here. I think this part's a little bit easier, right? Finding the radius, very simple algebra. The trig is where we get stuck up on. So the easier the trig circle is, the easier this problem will become. Again, the main takeaway here is this negative radius is what will flip back over into the quadrant that you want, right? So if you have a negative radius, whatever way you'd like to go, right? So if it's pointed at pi over 4, it's going to flip you the other way. So that's the reason why we had to go grab the angle that is 180 degrees in the opposite direction, so it flips us in the correct way. We'll do one more example of these in the next video, just in case you got lost. And of course, if questions, ask away in class. I will see you shortly. Last example for this video, same idea, going from polar to, from Cartesian to polar. And so we're going to put up our rules one more time in case we forgot. Again, for finding the radius. Let's see, there we go. X squared plus y squared is equal to r squared. And the other one, right, tangent of theta is equal to y over x. That is the simplified version. Okay. So the Cartesian coordinate that I'll give us, we'll do 4, and let's do negative 4 rad 3. Okay, let's see if this turns out nice. We'll try finding the radius first. So let's do x squared And of course, if you can do this, you don't have to, you can skip this step, but I'm just showing all of them. And negative 4 rad 3 squared. What do we have? 16 plus, this is 16 times 3. What do we get? 16 plus 48 is 64. Right? Again, though, what did we solve for? We solved for r squared. So r squared is equal to 64. So we have, again, two options, right? R can be positive 8, or r can be negative 8. Right, so again, your homework will ask you, give you one positive r and one negative r. Let's get another visual over here so maybe this makes a little bit more sense. All right, so if we have this coordinate where we get a b, we have a positive x and a negative y, so we're going to be in quadrant 4. Right, just to have a little bit of an idea here. That points somewhere down here maybe. Okay? We have our radius. Let's find our angle that goes with it. So tangent of theta is equal to y, negative 4 rad 3 over x 4. Right? So we just end up with negative rad 3. Okay? This is tangent of theta. So again, there are two different angles that are associated with this. Right? When do we have a negative, right? This is again, right, y over x. Right? So y over x, if we get a negative sign, that means one of these, only one of these is negative. Well, where does that happen? That either happens here, right, which will be the angle we use to flip back into quadrant 4, or it happens in quadrant 4 itself. So, let's think about which angle do we want? I'm going to give it away. We want, this is going to be pi over 3. And again, so this is all dealing with the reference angles from the trig circle, right? So at pi over 3, we have values of 1/2 and rad 3 over 2. Right, so in essence, or what's going to happen here, if we do tangent, you get rad 3 over 2 over 1/2, right? So this is why the 2's cancel out. We get rad 3. Right, so I know this is the right angle, the right reference angle. Now I want the one that's in quadrant 2, right? So I know that theta is going to be equal to 2 pi over 3. That is the angle that's referred to in quadrant 2, and there's also one that's in quadrant 4. All right, well, what is this? This is going to be 4 pi over 3. This is going to be 5 pi over 3. Okay, so now we have our angles, right? We have our radius, we have our angles. We need to know which one goes with which. So again, I know I want to be located in quadrant 4, right, based off my Cartesian coordinates. Right, so if I go positive 8 direction, right, meaning I don't want to switch directions, positive 8, the angle that I want to associate with this is going to be 5 pi over 3. So I have one answer, right, 8 comma 5 pi over 3. And this is obviously my r is greater than 0 because it's positive. However, right, if I use the angle associated in quadrant 2, which is the 2 pi over 3, and I want to end up in quadrant 4, I need to have the negative radius associated with it so it'll flip back, right? So you can imagine I'm heading 2 pi over 3. Well, I'm going in the wrong direction, but if I use a negative radius, it'll flip me back to where I want to go. So that is why this one has the negative 8. Right? And of course, r is less than 0. So those are my two options. Again, I always recommend drawing out some visual representation here so that we understand what actual point we're looking for. And of course, the only rules that we added here, right? This one's not too bad. Normally the angle one is the one that gives us a little bit of challenge, only because it's referring back to our knowledge on the trig circle, right? The easier the trig circle is, the easier this rule specifically becomes. So if we have questions again, feel free to ask them in class. Study the trig circle. Again, if you want me to go through that in class, ask away. I can go through quadrant 1 and explain how if we only know quadrant 1, we know the whole entire trig circle. All right, I will see you guys in class. Thanks.